Hey guys, I'm out again today, so you're stuck with the video of me, but I will be back tomorrow, I promise. So let's have a productive day. We are going to be working on box plots today, so hopefully you have those notes in front of you and your warm-up sheet. Alright, Tuesday warm-up. A set of data consists of the numbers 5, 1, 2, 4, 3, and 9. Which statement is true about this data set? Just pause this video for a couple minutes till everybody has a chance to try it, and then you can press play. Alright, so if I'm just looking through these answer choices, it looks like it mentions mean, median, and range. So I am going to find those three things and then look back at the choices. Alright, so mean is the average. That means I'm going to add the numbers together and divide by 6 because there's 6 numbers. Don't forget about that 9 over there after the word and. So we got 5 plus 1 is 6, plus 2 is 8, plus 4 is 12, plus 3 is 15, plus 9 is 24. So the sum is 24, dividing that by 6 numbers, the mean would be 4. Alright, median, that's where I need to put the numbers in order and then find what's in the middle. I'm going to do that over here so I have a little bit more room. I'm getting a little faster at writing with the mouse. Look at me go. Alright, we got 1, 2, 3, ooh, it's getting sloppy, 4, 5, and 9. Alright, let's see. If we start crossing off numbers on the ends, let me change the color here. If we go lowest, highest, second lowest, second highest, then we're stuck with a 3 and a 4. So mental math that. Halfway would be 3.5. That's our median. And the mode is the number that shows, oh, there is no mode on here, but if we were finding the mode, the number that shows up the most, there is no mode. So that's probably why they didn't include that. So the range is what we need to find next. Remember, range is just the biggest number minus the smallest number. So that would be 9 minus 1, which is 8. Okay, so let's see. Mean and median are both 4. Nope. Mean and range are both 4. Nope. Range is 4. Nope. Mean is 4. Median is 3.5. Boom. So I guess I didn't even really need to find the range, but good practice. Alright, let's see if all of this will erase. Dang it, it's always the ones on the right side that don't erase. That's weird. Alright, well, anyways, you should have your box plots notes in front of you. Not sure if you've ever seen a graph that looks like this before. It's kind of weird looking at first, but it's actually pretty simple to read once you get the hang of it. So I'm going to show you an example box plot before we start filling in the notes. And let me show you how to read it. Alright, so technically the full name is a box and whisker plot. We can just call it box plot for short. But it's called that because it has a box in the middle and then it has what's called whiskers on the side. So we could say this is the left whisker and this is the right whisker. So here's how we read this box plot. Basically, this point on the end of the whisker is the minimum, so that's the lowest number in the data set. The number on the other whisker is the maximum, the highest number. So we got 25 and 38. Then the left edge of the box tells you what Q1 would be. So that's the middle of the lower half. That looks like 29. The line that's inside the box tells you what Q2 is, or the median, so that's 32. And the right edge of the box tells you what Q3 is. So the middle of the upper half would be 35. So it pretty much just gives you a nice overall summary of the data. And you don't even need to see all the numbers in the data, you just see the most important 5 numbers. If you were trying to find the IQR of your data set, you're just doing Q3 minus Q1. So that's basically just the length of the box. So you would do 35 minus 29, which would be 5 for the IQR. If it asked you for the entire range, that would be the minimum subtracted from the maximum. So that would be 38 minus 25, 13. Also, the way that box plots are set up is they're split into quartiles, like we practiced yesterday, which basically means that the left whisker represents 25% of your data set. The left half of the box represents another 25%. The right half of the box represents another 25%. And the left whisker represents the last 25%. So you can kind of see how your data is spread out. So this one looks like perfectly symmetrical. It looks very even on both sides. That doesn't happen too often. A lot of times it'll be kind of leaning one way or another. So we'll look at a bunch of examples as we go. Alright, so let's see. I think let's do the notes and then we'll come back and try to analyze some of these on the slides. But let's start by filling in the parts of a box plot. Alright, a box plot displays data distribution using 5 key numbers. So let's start with the minimum. That's the smallest piece of data, or the lowest number. Then the median of the lower half is the first quartile, or I usually just call it Q1. You can write that next to it if you want. The median of the data would be the second quartile, or Q2. Median of the upper half would be the third quartile, Q3. And the largest piece of data is called the maximum. And then, just like we talked about yesterday, the difference between the first and the third quartile is called the interquartile range, which you can always just shorten it to IQR. But it would be good to write out the entire thing on your notes so you remember interquartile range, or IQR. So that's Q3 minus Q1. Alright, let's label these parts of the box plot. I usually like to put a dot on the edge of the whisker to represent the minimum. So I'll just put min for that. Then the left edge of the box would be Q1. The line inside the box is Q2. The right edge of the box is Q3. And the maximum is the edge of the right whisker. Alright, so let's try to read this box plot down here. It says fill in the 5 number summary. So that means we just need to fill in these 5 important numbers. You can see that the minimum is 11. Q1, let's just estimate and say it's about 12 to keep it easy, whole numbers. Median, definitely 14 on that line. Q3, looks like 16. And the maximum looks like 18. Then it says, what is the interquartile range? Remember, that's Q3 minus Q1. So the IQR is basically just from one end of the box to the other. So 16 minus 12 is 4. Alright, now we're going to try to make a box plot. It says the data set below lists the high temperature for each day last week in Austin, Texas. Fill in the 5-number summary and create a box plot to represent the data. Alright, so first thing I would do is put these numbers in order. Looks like 52 is the lowest, then 55, then 82, 84, 88. Oh, I missed 73. See, if you miss a number, that totally messes you up. So good thing I caught that. Alright, 52, 55, 73, 82, 84, 88, and 91. And there should be 7 numbers, so that's a good way to double check. 1, 2, 3, 4, 5, 6, 7. Alright, so if we want to start by filling in these 5 numbers, then that'll make it easy to make our box plot. So minimum, that's the lowest number, 52. I'm going to skip ahead to maximum because that's easy. That's 91. Then I would do median next so we can split it down the middle. So lowest, highest, second lowest, second highest, third lowest, third highest. The middle is 82. You could call that the median or Q2. Then we need to take these 3 numbers, the lower half, and find the middle, which is 55 for Q1. And take these 3 numbers, find the middle. That would be 88 for Q3. Alright, so before we make the box plot, we need to fill out the number line. So we could count by whatever we want, really. We just have to make sure that it fits all of these numbers. So maybe we start with 50, because it has to be able to include 52. And we need to make it at least to 91. So maybe we count by 5s, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. Yep, that would work. Alright, so here is what I would recommend. So you're going to make a line for the median. So 82 is the median. Estimate where 82 would be. You're going to make a vertical line. That's going to be the line that's inside the box. Then you're going to make another line for Q1, which is at 55. That is the left edge of the box. Then make a third line at Q3, that's 88. Estimate that. So you have 3 lines. We got Q1, Q2, Q3. It doesn't really matter which order. You could have started with Q1. But after you make those 3 lines, you are going to connect them on the top and connect them on the bottom. And that is going to form your box. And then the only thing left would be the whiskers. So the minimum is 52. So put a little dot around 52 and connect that to the box. And let's see, 91 is the maximum. Connect that. And there you go. So you can see this one is not symmetrical. This one looks like it's skewed. So see how the median is all the way up here? If somebody were reading this box plot, that would tell them that most of the days were pretty warm, but there were a couple days that really stretched it down in the 50s. So if it were perfectly symmetrical, that would mean like half of the days were cold, half of the days were hot, but since the median is pulled up to the right, that means it was generally in the 80s. Alright, so now let's go back to this example. So this is a box plot showing the ages of the players on the Knicks. So this is an NBA basketball team. So just by glancing at this, I can tell that the entire team is between 19 and 39 years old. I could also tell the median is 26 and a half. And Q1 is 24, Q3 close to 29, we could just say about 29. So you need to remember that each quartile represents 25%. So 25% of the team is between 19 and 24. 25% of the team is between 24 and 26 and a half. Another 25% is between 26 and a half and 29. And another 25% is between 29 and 39. So that means half the team is between 24 and 29. So that's like when players are in their prime. That's the place to be. And then it looks like once the players get older, there's not so many players left on the team because a quarter of the team is in this huge range. So there must only be a couple of old players up here. So let me show you what data set I used to make this box plot. These are the exact numbers of the players on the team. So yep, you can see there's one player that's 39, but the second oldest player is 32. So there's only a few players in their 30s. Most of the players are in their 20s, and there's only one 19-year-old. So that's basically an easier way than, instead of listing all of these numbers, if you just show somebody the box plot, that gives you the overall summary of the data, which is nice. Alright, so let's compare these two. We got the one we just looked at for the Knicks, and then this is the ages of players on the Yankees, the baseball team. So if you just kind of look at the overview of these two box plots, which team do you think is overall a little bit older than the other team? If you said the Yankees, you are correct. Because even though the Knicks have the oldest player at 39, if you look at where this box is, half the team is in here for the Yankees. So half their team is between 26 and 32. Whereas the Knicks, they're down here in their 20s. So see how the Yankees box plot is pushed a little bit more to the right? That means in general, they're a little bit older. Also, their youngest player is 22, so everything is pushed a little bit to the right, except for that maximum, but that's just one person, so that doesn't matter too much. So when I said they're pushed a little bit to the right or the left, that means skewed. It's kind of weird because left skewed means it's pushed a little bit to the right, and right skewed means it's pushed a little bit to the left. So see how the median is to the right? That means it's skewed left. Median is to the left, that means it's skewed right. And sometimes you'll have symmetrical box plots where it's perfectly lined up. But more often than not, it'll be a little bit skewed. Alright, so let's practice answering some questions about box plots. Think about what was the median score. If you said 75, you are correct. We're just looking at that line in the middle. What was the range of the test scores? If you said 40, you're correct, because that's 100 minus 60, 40 points, or 40%. Then it says, what percentage of the scores were between 60 and 70? If you said 25%, you are correct, because that's just 1/4 of the data. Oh, I'm going to have to erase it by hand again. I don't know why that keeps happening. Let me just erase most of it. It's not that serious. Alright, let's look at another one. Hours slept. Whoops, let me go back. Alright, think about what was the median hours slept. That should be pretty obvious. That is 8. Think about what is the third quartile. Q1, Q2, Q3. That would be 9. And what percentage of people slept at least 6 hours? Think about that. That means 6 or more. So that would be 25, 50, 75%. 3/4 of the box plot. Alright, last thing we're going to do before you work on your own. So we're going to look at one more slide. We're going to compare two box plots, kind of like we did with the Yankees and the Knicks. Let me see if I can erase most of that. Oh man, this is driving me crazy. I really need to learn how to make that bigger. Okay, that should be good enough. Alright. Let me skip ahead to this slide. Oh, I got to erase that too. Okay. Alright, so use the box plots shown below to type your solution to each question on the right. Each year, members of the art club sell paintings in order to raise money. The amounts of money raised by the members over the last 2 years are shown below. So, question A says, which year had the greatest range, and what was the range? So remember, range, that is the maximum minus the minimum. So 2018, we would go 130 minus 70. That would be 60. I guess I could just write that on here for now. Then if we find the range of 2019, that's 120 minus 50, which would be 70. So 2019 had the bigger range, and you might be able to tell just by looking at it because it's the wider box plot. So sometimes it's pretty obvious. 2019 had a range of 70. Alright, next question. Which year had the greatest median? That's pretty obvious. That's just a line inside the box. So we got 100 here, we got 80 here. So 2018 wins for that one. Median is 100. Alright, which year had the greatest IQR? And what was the IQR? Remember, that's just the box. So I'm just by eyeballing it, I can tell it's going to be 2018 because that has a bigger box. It goes from 80 to 120. That would be 40. This one only goes from 60 to 90. That would only be 30. So 2018 had a greater IQR, which was 40. And which year shows more symmetry? Looks like 2018. It's balanced on both sides. 2018. 2019 is a little bit skewed to the left. Actually, wait. No, it's skewed to the right. I got that backwards. Alright, so you guys are going to be doing pretty much the same thing that you did yesterday. Let me put the directions back up there for you. Alright, so you're going to go to the Unit 10 agenda, open up today's slides. I think there's a bunch of them today, so see how much you can get done. Again, when you're done, check the answer key on the stream page, and if you finish all of them, you can grab a homework and get started on that. Alright, I'll see y'all tomorrow. Peace.